Accidents in research laboratories are not isolated events. Since 2001, the CSB has gathered preliminary information on 120 explosions, fires, and chemical releases at university laboratories and other research facilities around the country. The accidents have caused deaths, serious injuries, and extensive property damage. On December 29, 2008, when most of the campus was closed for holiday vacation, Sherry Sanji was working on a research project at the UCLA Chemistry Department. According to a report by California State OSHA, Ms. Sanji was using a syringe to transfer a solution of tertiary butyl lithium, a dangerous pyrophoric chemical that ignites spontaneously on contact with air. Chemist Dr. Jillian Kemsley reported extensively about the UCLA accident for Chemical and Engineering News, using documents obtained under California open records laws. California OSHA cited UCLA's chemistry department for failing to require appropriate body protection for laboratory workers handling pyrophoric materials. An internal UCLA safety inspection of the same laboratory just 2 months prior to the accident found that personal protective equipment was not fully utilized by laboratory personnel. Yet on the day of the accident, Ms. Sanji had neither a flame-resistant lab coat nor the much more extensive protective clothing recommended by manufacturers of pyrophoric chemicals. Dr. Kemsley believes that even a flame-resistant lab coat would have helped. And though the university said it provided adequate safety training for workers, California OSHA found no documented evidence of this. Dr. James Gibson, director of UCLA's Environment, Health, and Safety Office, says UCLA has taken steps to improve safety accountability and oversight, improve training, provide proper protective equipment, conduct unannounced safety inspections, and improve laboratory safety culture. Dr. Gibson urges other universities to take steps to improve their education, training, and safety culture.
Once we get people to do that, we're going to see a dramatic decrease in the number of accidents that occur.
In August 1996, acclaimed Professor Karen Wetterhahn was conducting research on the biological impacts of heavy metals in her lab at Dartmouth College. She was working with small amounts of a highly toxic compound called dimethylmercury. She used a mechanical pipetting device to transfer the liquid compound while wearing latex rubber gloves. During this process, she later told colleagues, 1 or 2 drops landed on her gloved left hand. Dr. John Wynn is a professor of chemistry at Dartmouth College, where he has worked for almost 30 years. At the time of Karen Wetterhahn's accident, he was chair of the chemistry department. At the time, Professor Wynn said, no one in the department knew that dimethylmercury could seep through the latex rubber gloves worn by Professor Wetterhahn. But 5 months later, in January 1997, she began to show serious neurologic symptoms as her balance, gait, and speech deteriorated rapidly. Despite medical treatment for heavy metal poisoning, 3 weeks later, she became unresponsive and died in June 1997, 10 months after the accident. According to Dartmouth officials, Professor Wetterhahn had consulted the material safety data sheet for dimethylmercury, which advised the use of latex rubber gloves when handling the material. Professor Wynn says the tragedy led the university to emphasize the need for comprehensive hazard evaluations, rather than relying exclusively on the safety precautions from chemical suppliers. In January 2010, 2 graduate students at Texas Tech University were conducting research on energetic or explosive compounds, funded by the U.S. Department of Homeland Security. The students were tasked with synthesizing and performing tests on a new compound, a derivative of nickel hydrazine perchlorate. Initially, the compound was made in small batches of less than 300 milligrams. But the two students were concerned about potential variability among different small batches of the compound, which could affect later test results. So they decided to scale up the synthesis to make a single batch of approximately 10 grams, enough for all of their testing. They believed that keeping the solid compound wet with the solvent would keep it from exploding. After producing the larger batch, the more senior graduate student observed that it contained clumps that he believed needed to be broken up prior to testing. While wearing safety goggles, he transferred half of the new compound into a mortar, covered the compound with a solvent, and used a pestle to gently break up the clumps. After some time, he took his goggles off and walked away. A short time later, he decided to stir the compound once again. He did not replace his goggles. As the pestle pressed against the compound, it detonated. The graduate student was seriously injured, his left hand severely damaged by the force of the explosion, causing the loss of 3 fingers, perforation of his eye, and cuts and burns to other parts of his body. Post-accident photos and video show extensive damage as the explosion fractured the lab bench, shattered bottles, and sprayed the lab with projectiles. Professor Dominic Casadante was head of the Texas Tech Chemistry Department at the time of the accident. The CSB investigation at Texas Tech found deficiencies in each layer of safety management within the institution. These included insufficient safety accountability and oversight by the principal investigators, the chemistry department, and the university's administration. And according to investigators, there were also important gaps beyond the university itself. The victim at Texas Tech had been working on the energetic materials project for about a year at the time of the accident. But the CSB found that he did not receive any specific formal training on working with potentially explosive compounds. The two principal investigators believed they had verbally established a 100 milligram limit on the production of energetic materials. But the CSB investigation found there was no formal system for communicating this limit or verifying compliance. None of the lab researchers believed that a strict 100 milligram limit existed. The CSB found that the use of personal protective equipment within Texas Tech laboratories was not consistently enforced. Dr. Taylor Amy is the Vice President for Research at Texas Tech University. Since the accident, Texas Tech has modified its organizational structure so that the Environmental Health and Safety Director reports to Dr. Amy, who also has authority over the principal investigators. The CSB investigation determined there had been 2 previous near misses within the laboratories of the same principal investigators since 2007. While no one was injured, CSB investigators concluded there were similarities in the causes of these incidents to the January 2010 explosion. But these key lessons were missed at the time of the earlier incidents. The CSB determined that the Department of Homeland Security, which funded the research at Texas Tech through an agreement with Northeastern University, had a general condition stating that the safety of researchers was the responsibility of the various host institutions. However, DHS did not impose any specific safety requirements for research with energetic materials, and Texas Tech did not evaluate the hazards or develop any specific university safety policies. Because Texas Tech is a public institution in a state that lacks its own workplace safety program, it is not required to abide by the federal OSHA laboratory safety standard. But Texas Tech officials did voluntarily develop a chemical hygiene plan, using the OSHA laboratory standard as guidance. To highlight this gap in the laboratory standard, the CSB recommended that OSHA issue a safety bulletin on the importance of controlling physical hazards of chemicals in the laboratory. And the CSB noted that no comprehensive guidance exists for conducting hazard evaluations within the dynamic environment of academic research laboratories. As a result, the Chemical Safety Board recommended that the American Chemical Society develop a methodology for evaluating and controlling hazards in academic research laboratories. The board also recommended that Texas Tech University should revise and expand its chemical hygiene plan to ensure that the physical hazards of chemicals are controlled, and develop and implement an incident and near-miss reporting system. Dr. James Kaufman is the president of the Laboratories Safety Institute, a nonprofit organization which provides safety training for universities. To achieve a high safety standard, the CSB investigation identified key laboratory safety lessons for universities. Ensure that research-specific hazards are evaluated and then controlled by developing specific written protocols and training. Expand existing laboratory safety plans to address the physical hazards of chemicals. Ensure that safety personnel report directly to a university official who has the authority to oversee research laboratories and implement safety improvements. Document and communicate all laboratory near misses and incidents.
Exploring the unknown, doing research, always involves risks. Those risks are worth taking. We know that as a society. And as a society, we owe it to ourselves to do them in the most efficacious and safe ways